right, you guys, so concept 2, we are going to be checking to see if a number is a solution, because believe it or not, there are some numbers that are solutions and some numbers that are not solutions to an inequality. So we are looking to see, is a number a solution to the inequality? Well, if it is, that means that it will be shaded on the graph. When I do my little number line graph and I shade my values, it'll be shaded. And what it means, if it is shaded on the graph, that means it's a solution, which means that if I were to plug it back in, it would make a true statement in that equation. So let's take a look at an example over here real quick. If I said x values that are greater than or equal to 2. Well, let's test a value. Let's plug something in. Let's plug in the number 6. If I plugged in 6, this would be 6 is greater than or equal to 2. Is that true? Yes. So 6 is a solution. But what if I plugged in -3? If I plug in -3 for x, then I have -3 is greater than or equal to 2. Is that true? No, that's not true. So -3 is not a solution. So we're looking for numbers that if we were to plug them in would make a true statement mathematically. So let's take a look. We're going to do numbers 19 through 29 together in the video, and then you are going to tackle 20 through 30 on your own. So let's take a look. Our first one we have is a is greater than or equal to 4, and I'm just making it a little bit bigger so it's easier to see. So first off, I see that this is equal to 4, so that means I'm going to find 4 and I'm going to do a closed in circle, and then I'm going to shade in, yoink, that direction. So I get my highlighter and I shade in that direction. Then I'm going to come over here to this table and I'm going to look at number 19, which is the problem that I just did. And I'm going to check the boxes that are solutions. Well, I know that it starts at 4, so anything less than 4 is not going to work. But 4 is a solution because it could be equal to 4. And 5 is a solution because 5 is greater than 4. So those are my two solutions. Out of these numbers, these are the two that would work or would be considered solutions for number 19. Let's take a look at number 21. Ooh, 21 is backwards, so I'm going to have to rewrite it in the correct order. So I start with my variable. Now for my symbol, let's see. The open up side, or the big side, is close to my x, so I'm going to keep the big side close to my x. There's no equal sign, and my number is -3. So since there's no equal sign, at -3 I'm going to do an open circle. An open circle because -3 is not included. It is not a solution. So let's see, and I'm going to shade in, let me see, oh, that direction. So starting at -3, shade this way. So let's see. This is number 21, so I'm going to find 21 on my table. Is -5 a solution? No, it's not shaded. -3, nope, it's not shaded. It's not colored in because I used an open circle. But -1 is, 0 is, all of these that are greater than -3 are all shaded in, so those are all solutions. Number 23 is another backwards one. So I'm going to start with my variable first. I'm going to rewrite this. I am going to keep the open side of my symbol close to the n, and it does have an equal sign, and my number is 1. So that means on my number line, at the number 1, I will put a closed in circle because 1 is included in my solutions. And to see which direction I shade, I'm going to turn my symbol into an arrow, and I'm going to shade this way. All right, so over to my table. -5 is not shaded. -3 is not shaded. None of the negatives are shaded, and 0 is not shaded either. 1 is shaded because I used a closed in circle. And that means that all of these that are greater than 1 are solutions as well. And if you check on your little number line, they're all shaded in. 25. 25 starts at -6, and it's going to be x values. Let's see. It goes this way, so my symbol is going to match the end of my arrow. So it's x values greater than, this little dot is colored in, so that means it's equal to, and my number is -6. So x values that are greater than or equal to -6. So let's see what's shaded for number 25. -5 is shaded. and all of the values greater than that are shaded. So these are all solutions. These are all shaded values on my number line, and if I were to plug them in, they would give me a true statement. How about 27? Well, 27 starts at 4, so I've got x and 4. 4 is shaded in, so I know it will be equal, and my end of my arrow is pointing this way, so I'm going to do my greater than symbol. So x values that are greater than or equal to 4, just so you can see it a little better, all of my shading is here. So let's see. Anything smaller than 4 is not going to be shaded. So it will be 4 because 4 was shaded in by my dot because it was a colored in circle or a closed circle. And 5 is greater than 4, so that's a solution as well. How about for 29? 29, let's see, we'll have our variable and our number is -4. It's shaded in, which means -4 can be a solution, so it could be equal to, I'm going to put my little equal to line there. And then the end of my shading arrow, because it goes this way, the end of my shading arrow makes this a greater than problem. So let's see, x value is greater than or equal to -4. Well, -5, that's not shaded, so that doesn't count. Let's see, -3, yep, that's shaded. -1 is shaded. All of these are shaded because we want the x values that are greater than -4. So that would include all of these. All right. Hope you enjoyed trying to find if a number is a solution to the inequality. Just remember, go ahead and shade it on your number line and then check to see, is this shaded, yes or no? If it's yes, then it's a solution. If it's no, then it's not. Check the ones that are solutions and come to class ready to discuss your summary.